Lesson 5. Introduction to Arduino. Contents. The topics covered in this lesson are microcontrollers and microprocessors, introduction to Arduino, types of Arduino boards, the structure of a code. The tasks and/or activities for this lesson include blink on board LED, blinking one and more LEDs, experimenting with LEDs, for example, changing brightness of LEDs. What is a microcontroller? It is a small computer on a single chip containing a processor, memory, and input or output as its main components. It is compact and is embedded inside a device that is controlled. It is of low cost and often very small. The key difference between a microprocessor and a microcontroller: microprocessor consists of only a central processing unit, CPU, whereas a microcontroller contains CPU, memory, input and output devices all integrated into one chip. What is the difference between a computer and a microprocessor and a microcontroller? Microprocessor is a full computation engine fabricated on a single chip. It acts as the central processing unit of a microcomputer. A computer is a microprocessor packaged on a single circuit board with many interfaces and memory chips. General-purpose computers are designed explicitly to interface with humans. Microcontrollers are designed to interface, interact, and communicate with electrical or electronic devices, sensor or actuators, high-tech gadgets, and more. The components of a robot are power conversion unit, which is a battery power the system. Actuators or motors generally attached to the parts in mobile robot that need actuation or movement. Controller is the brain of the system. It can independently or via input and output devices like switches, push buttons, sensors, LCD displays, relays, and controls various processes and devices such as industrial automation, electric current, temperature, engine performance. Sensors measure the robot condition and its environment and send such information to robot controller as electronic signals. User interface can be a joystick, mobile application, or a coding interface such as an IDE. Base is the chassis of the mobile robot, which is mounted with the manipulator and all the other components. Let's talk about Arduino. What is Arduino? Arduino is an open-source electronic platform for easy use of hardware connected to it and software to run it. It can sense the environment by receiving input from variety of sensors and make decision and then give the output. It can be used to develop standalone interactive objects or can be connected to software on your computer. What does a microcontroller do? The microcontroller is programmed to receive information from the sensors and the output is given through a computer or other peripherals. Activity 1. What is the circuit doing? What elements do you see on the circuit? Is there any input? If yes, what is the input? Is there any output? If yes, what is the output? Solution for Activity 1. What is the circuit doing? Answer. Light up the onboard LED on button press. What elements do you see on the circuit? Answer. Button, resistor, wires. Is there any input? Answer. Yes. If yes, what is the input? Answer. Button. Is there any output? Answer. Yes. If yes, what is the output? Answer. LED. The word Arduino can mean three things: a piece of hardware, an interface to communicate with the hardware, a community of Arduino-related projects and resources. Different types of Arduino. Arduino Nano. It is one of the smallest Arduino boards with no power jack. Arduino Micro. It is the smallest Arduino board like Arduino Leonardo but with the ability to use keyboard and mouse. Arduino LilyPad. It is a low-power board version designed for wearables like watches. Arduino Uno R3. It is a relatively large board and used for DIY and beginner projects as a learning board. This is the board we utilize in this course structure to work on projects. Arduino Leonardo. With same features as Uno R3, it is easily human interfaceable device and can be used as a keyboard or mouse with a USB cable attached. Enhanced boards. These are the boards with added features into them to use in varied applications. Arduino MKR. It comes with an expandable storage and music making ability. Arduino IoT. It is similar in design to MKR. It comes with the ability of connectivity through Wi-Fi, GSM, and Foxcloud. Arduino Mega. It is almost similar to Arduino Uno, but this board comes with higher set of pins. A few examples of projects based on Arduino are shown. Rubik's Cube Solver. Line Following Turtlebot. Spiderbot with Arduino. LED Cube powered by Arduino. App-controlled trainable arm with Arduino. An example of a human-following cooler called Follow Me is shown here. It carries a cooler and follows a human around. The robot cooler connects to a smartphone via Bluetooth and uses GPS to navigate. All the electronics are placed on the base or the chassis to be able to carry other objects on the top. Similar to the above example, a human following luggage with Arduino was developed at NYU. As shown in the video, it carries luggage and follows human around. An example of a voice assistant called Jarvis with Arduino developed at NYU. As shown in the video, it executes the commands of closing and opening the door lock by voice recognition technology.
Hey Jarvis.
Yes, sir.
Open the door for me.
Okay, sir.
Hey Jarvis.
Yes, sir.
Close the door for me.
Sure, sir.
Hey Jarvis.
Yes, sir.
Switch on the light.
Okay, sir.
Arduino Uno development board. The parts of the board and their functions are described below. USB plug. Arduino board can be powered by using the USB cable from your computer. External power supply. Arduino boards can be powered directly from the AC mains power supply by connecting it to the barrel jack. Reset button. You can reset your Arduino board, that is, start your program from the beginning by pressing on to this button. You can also reset by using the reset pin on the board. 3.3 volt power pin, a supply of 3.3 output volt. 5 volt power pin, a supply of 5 output volt. There are several ground pins on the Arduino, any of which can be used to ground the circuit. Voltage in pin also can be used to power the Arduino board from an external power source, like AC power supply. The Arduino Uno board has 6 analog input pins A0 through A5. These pins can read the signal from an analog sensor and convert it into a digital value to be read by the microprocessor. The Arduino Uno board has 14 digital input or output pins, of which 6 provide pulse width modulation output. These pins work as input digital pins to read logic values 0 or 1, or as digital output pins to drive different modules. TX and RX pins are used for serial communication. The TX LED and RX LED internally connected to digital pins 0 and 1 to show what way the serial communication is taking place. In addition to the above LEDs, there is also an onboard LED internally connected to digital pin 13. There is also a power-up pin which blinks when the Arduino is powered. Analog reference pin is used to set an external reference voltage between 0 and 5 volts. ATmega 328 microcontroller is on which the Arduino board is built. This gives a summary of all the pins on the Arduino discussed above. Activity 2. Download and install the Arduino environment according to your Mac or Windows system. Connect the board to your computer via the USB cable. If needed, install the drivers. Launch the Arduino IDE. Powering up the Arduino with USB. Connect the Arduino via USB cable to load the code and provide power at the same time. Select the board Arduino Uno and the port showing in the serial port section. Now the board is ready for serial communication. Let us do an activity to check it out. Activity 3. Blink the onboard LED. Select your board. Select your serial port. Open the blink example. Upload the program. Activity 3. Blink the onboard LED. Select your board. Select your serial port. Open the blink example. Upload the program. Activity 3 solution. Go to File, then Examples, then to Digital, and then to Blink to access the onboard LED blinking program. Upload the code with right arrow symbol from the menu and watch the LED blink. A little bit about the code. Sketch. Arduino code is referred to as Sketch and consists of void setup. Instructions between the two curly brackets will be run only once when the Arduino program first runs and used for the purpose of setup. We have to initialize input-output pins, initialize serial communication, or sometimes also write a piece of code which need to be run only once in here. Void loop. This function is run after setup has finished. It runs in a continuous loop until power is removed. Basic rules of programming Arduino. // It is used for writing a single-line comment. Multi-line comment, or a block of comments, can be written in between a /* and a */. Curly braces indicate starting and ending of a block of code. Unbalanced curly braces will cause compile time errors. Each line of code must end with a semicolon. As a note, semicolon should not be used after #include, #define, if, else statements, and for, while loops if code is inside the curly braces. Programming input-output pins. Pin mode. Pin, mode. Pin refers to digital input-output pin number and mode argument refers to input or output states. We can use digital input-output pins 2 to 13 because 0 and 1 used for RX and TX. Digital input-output pins have default state as input, so there is no need to explicitly declare as inputs. Uploading your code. Select your board Arduino Uno. Select your port from Tools. Upload the code to the Arduino as shown. Check for errors. Check if the code is compiled successfully. Blink an external LED. Make the connections as follows. Things to remember. Longer leg or anode of the LED goes to one end of the resistor in series and the other end of resistor goes to pin 3 here. Shorter leg or cathode goes to ground G end. Activity 4. Write a program to blink one external LED using Arduino. The following components are needed to successfully complete the activities ahead. 5 LEDs. Arduino microcontroller board. Jumper wires. Breadboard. Resistors of 220 ohm. Activity 4 solution. Make connections with LED connected to pin 6 in series with a 220 ohm resistor as shown. The code is as follows. Digital input-output pins. They are numbered from 0 to 13 on the Arduino Uno board. The connections are made to drive different sensors which need digital signals as input and output. Now we will discuss how to work with digital pins. Digital red pin. It reads the value from the specified digital pin number, and the result is 1 meaning high or 0 meaning low. Pin can be specified as a variable, or constant from 0 to 13. Syntax. Value equals digital read, pin. This sets value equal to the state of the input pin. Digital write, pin value. Pin refers to a digital pin, can be a variable or a constant from 0 to 13. Value is either logic level high or low, true or false, 1 or 0. Outputs either logic level high, or low, at a specified digital pin. Now we will discuss how to work with the analog pins. Analog red pin. It reads the value from a specified analog pin with a 10-bit resolution. The pin argument can be specified as a variable, or constant from 0 to 5. Resulting integer values range from 0 to 1023 and must be scaled to appropriate units. Syntax. Value equals analog read, pin. It sets value equal to analog reading on pin analog write, pin, value. This outputs a PWM signal to the specified output pin. This function works on digital pins 3, 5, 6, 9, 10, and 11. Value can be specified as a variable, or constant with range 0 to 255. Syntax. Analog write, pin, value. It writes value in value variable to specified pin. Activity 5. Attach 2 LEDs to your Arduino, each to a separate pin. Blink one LED only once and the other repeatedly. Activity 5 solution. Connections. The given 2 LEDs are connected pins 10 and 11 via resistors and ground pin. The code for the program is as follows. Let us discuss how serial communication takes place through Arduino. Serial begin rate. This command opens serial port and sets the baud rate for serial data transmission through the rate specified. Typical baud rate for communicating with PC is 9600, although other speeds are supported. When using serial communication, digital pins 0 that is for RX and 1 that is for TX cannot be used at the same time. Delay. This command pauses the program for time as specified in milliseconds, with 1000 being equal to 1 second. PWM basic concepts. Pulse width modulation converts a digital value to analog output. Pulse width modulation allows Arduino to generate a series of pulses or a square wave, which is the signal switching between on and off. The on time is output high, which gives an apparent 5 volts or 3.3 volts at the pin. The off time is output low, gives an apparent voltage of 0 volts at the pin. The duration of the on time, which is the high pulse, is called the pulse width of the signal. Duty cycle. It is the fraction of the period the signal is active or high. Higher the duty cycle, higher is the voltage at the pin. Duty specifies the analog output level as a fraction of 256 of 5V, ranging from 0 to 4.98 volts. Analog write function takes a value off 0 to 255, such that 255 requests a 100% duty cycle or always on, and 127 is a 50% duty cycle. Duty cycle is calculated with the following formula. On time over, on time plus off time. Activity 6. Attach one LED to your Arduino and write a program to change its brightness. Activity 6 solution. Make connections with LED connected to pin 6 in series with a 220 ohm resistor and ground as shown. The code is as follows. Status messages. When we upload our code to Arduino, it is possible that we get errors. Those errors are generally of 4 types. They denote the status of the code. Case 1. Successful upload happens when the bottom bar turns green and says done uploading. This means that the code compiled with no errors and uploaded to board successfully. The code is up and running at this point. Case 2. Error in compiling happens when there is any syntax error within the code. In this case, it is necessary to recheck the code lines to identify errors. Case 3. When a wrong port is selected for serial communication, an error occurs because there is no path open for the serial communication to happen. Case 4. If you select the wrong Arduino board, this error occurs. Make sure you select the same board from the menu, which you are working with. Activity 7. Attach at least 5 LEDs to your Arduino, each to a separate pin. Blink them together. Make connections with the LEDs connected to pin 3, 6, 9, 10, 11 in series with a 220 ohm resistor each and ground as shown. Do not forget to check the anode and cathode leads of the LEDs if they are placed in the right direction. The code is as follows. You can see the LEDs blinking high and low together with a gap of 1 second in between. Variables. A variable is a place to store a piece of data. It has a name, a value, a type and size accordingly. The syntax for declaring a variable is variable type, variable, name equals value of the variable. There are 5 types of variables which are used most frequently during the coding of a program. Boolean is of size 1 byte and stores either 1 or 0 corresponding to true or false. Character type is of size 1 byte and store a single character enclosed within single or double quotes. Integer type is of size 2 bytes and stores positive and negative integer values from -32768 to 32767. Float is of size 4 bytes which stores positive and negative decimal numbers. Long is of size 4 bytes, which is a higher storage type for integer, which stores numbers from -2,147,483,648 to 2,147,483,647. Let us see a few examples here. When a, b and c are declared as type integer, 50 divided by 30 should give 1.66. As c is type integer, only the integer part of the number is taken. So, the answer is 1. When a and b declared as type integer, and c is declared as type float, the answer is 1.66. When a, b and c are declared as type float, the answer is 1.66. When a and b are declared as type float and c as type integer, 50 divided by 30 should give 1.66. As c is type integer, only the integer part of the number is taken. So, the answer is 1. Activity 8. Divide 5 by 2 and store the value as integer and as float. Activity 8 solution. The solution is as follows. Thank you.